There is one series I am planning to start. So what this series will contain, it will contain the all of the important questions which you need to prepare before going to any coding interviews. In this series, mainly I will focus on the data structure. There will be one more series coming that will be based on the algorithms part. Now, in case of data structure, what are the topic we need to cover before going to any interview, which is very important. You cannot go for any SD1, SD2 interviews without preparation. And if you are planning to go for any interview in the product-based company, data structure algorithm plays very important role. So my first plan is to cover the data structure. What are the topics you need to cover? So let me show you those things and we will start one by one. All right. So important topic to cover in the data structure. We have the array, we have stack, queue, linked list, tree, and the basic graph. Because most of the companies are not going up to the graph, there are only very few companies which are talking about the graph questions. So we will go for the graph also, but the basic questions like breadth first search, depth first search, how to find cycle in the directed graph, and these kind of basic questions. What is the topological sorting? Those things we'll discover. Now, my first plan is to cover the 75 questions from these six topics. Now, array is most important one. Array and tree is the most important one. From array, I have taken 30 questions. From stack, I have taken 5 questions. From queue, I have taken 5 questions. From linked list, 10 questions. From tree, 20 questions. From graph, 5 questions. This is the first target you need to achieve. Let's say in 15 days, you are able to complete all these 75 questions. We'll plan the next 50 questions, next 70 questions, we'll decide. So, but this is the first target everybody should cover before going to any coding interviews. If you will go without covering these questions, it will be difficult for you. Now, we first of all, we will cover the array, 30 questions. Now, in the array, what are the very important categories are like searching in an array. We need to use the binary search, linear search, which one is important. We'll see based on the questions. Now, next category will be matrix based questions. Matrix based questions, like you have given one matrix, you need to print the spiral order of the matrix. And next will be like you need to rotate the matrix by 90 degree, by 180 degree, that can be anything. So those are the questions. Next we will cover about the sorting related questions, where you need to use the sorting and you need to perform some actions to get the answer. Next will be my favorite one, is the two-pointer approach. What is the two-pointer approach? Today I will start with the two-pointer approach, and there are 6 questions I have taken for the two-pointer technique. So today I'll explain you what is two-pointer approach. I'll explain you first question out of those 6 questions, and I will recommend you please try to solve next 5 questions by yourself. I will be making videos on those also, but I would say first you should try once. Think about the question and how you can solve the problem. Can you use the two-pointer approach or not? Just think about, just give it a try. All right, so now main target is what is two-pointer approach. Two-pointer approach is nothing but a algorithm technique in which we'll use 2 pointers to solve the problem. Now, what are these 2 pointers? These 2 pointers are nothing but the index of 2 elements in the array. So we'll keep moving those 2 indexes to and fro, and based on that we'll solve the problem. Now we'll do the dry run nowadays. Before going to the dry run, let us take one example. One question we will see. So you have given one array. Okay, let's say this is the array in which you need to find out a key, a pair whose sum is equal to the given x. So for example, we'll see here that you have given 70 is the key. You need to find a pair whose sum is equal to 70. So you will see 5, 75, no, 10 and 60. So first pair will be 10 and 70, 10 and 60. You are getting 70, right? Second pair will be 30 plus 40, and third will be no. These are the two only. Yeah. But as per this question, let's make it very simple. You just need to print the first pair and you are done. Stop after printing the first pair. And you can print any one of them. I'm not saying you need to print this one only. But just print the one and no need to take care about the other pairs. We can have the multiple pairs, no issues. Now, so let's say this is the answer which we got, and we will not go for the second pair, we'll just print this one. Now what is the first approach that is coming to your mind? Think about it. Pause the video and think about it. So the first approach which is coming to my mind is what I'll do. I'll just run the two loops. So I will just run two loops. So let's say the loop will be like I0 to I less than n and I plus plus. There will be one more loop which is the inner loop. You will say, hey, I from I plus j plus 1, j less than n, j plus plus. Right? Now you will just calculate the int sum, which is the array of I plus array of j. Alright? You will compare this. If sum is equals to key, you got the answer. And you will just print the array of I and array of j, that is your pair. This is the approach which will always work. Nothing wrong in this approach. The only problem with this approach is how much time it is taking. So we'll think about the time complexity. We will think about the time complexity. Okay. So time complexity here, it will be O of n square because we are running two loops. Loop inside, you can see loop inside loop we are running. So the time complexity of this approach is O of n square, which is the polynomial time complexity. So the next thing which is coming to my mind is, hey, can we optimize it somehow? So I would say, please stop the video and think about the optimization. Okay, so the next important thing is how we can optimize it. Can we do it or not? Yes, we can do it. So the approach we'll use is the two-pointer approach, which I discussed here. With the help of two-pointer approach, we can optimize this problem. Now, just like binary search, you have seen, hey, for binary search, our array should be sorted. Here also, if you are applying the two-pointer approach, your array should be sorted. So first thing, you need to sort the array. All right. And then we will apply the two-pointer approach. Okay, let me explain you with an example how this two-pointer approach works. So this is the example. This is the same example which I was showing you with the two loops. Now, here key is 70. This is the array 5, 30, 10. Now I just sorted this array. It cannot be, so in the question might be possible that you will get the array which is not sorted. So first thing, you need to sort the array. After sorting, you will get, hey, 5, this is the array. Now we have the key 70. You need to find a pair whose sum is 70. Now what are these two pointers? So we will take two pointers. One is the low, one is the high. So low and high will keep, low will be the first element in the array, high will be the last element in the array. So in this example, low will be 0, high will be 6. Now what we need to do with this low and high? We will calculate the sum of these two numbers. So you can see step 1 here in the red color. So we'll calculate the current sum, which is area of low plus area of high. You got the current sum. Once you got the current sum is 5 plus 70, which is 75. You need to apply the first check. If 75 is equals to a key, which is not true in this case, we'll go to else part. If current sum, which is 75, greater than key, which is 70, then you just need to decrement the high. You will say, hey, why we are decrementing? Let me explain you. You know your array is sorted, and summation of these two numbers is greater than the key. You want to get the sum which is same as the sum key. Okay, so if you will increment the low, let's say, okay, in this case you will increment the low, the value of area of low will also increase because we are moving right side and the array is sorted, so right will be always greater than the left side element. So if you will increase the low, you will never reach to that 70 because it will keep increasing. So you want to decrease the sum. What you need to do, you need to decrement the high, because the value of high, if you will come left side, it will be smaller than the previous high value. So if you will decrement, high will come from 6 to 5. Okay, you can see in this diagram. Now our low is 0, high is 5. We will do this next step, which is in the blue color. So current sum will be 5 plus area of high, which is 5. So 5 plus 60, 65. Compare 65 with the key. Key is 70. They are not same. Now 65 is greater than the 70. No. We'll come to else part. We'll increment the low this time. Our low will be 1 now. We'll come to the third part. So area of 1, which is 10, plus area of 5, which is 60, total is 70. 70 is same as the key. Hey, yes, that means we got the answer. We'll print it, we'll break from the loop. So we got the two pairs. We got the pair which is made from 10 and 60, right? That is the approach, how this two-pointer approach will work. Now let us jump to the code part. So here I have taken one array. You can see, let me modify it to the same. Let's say 5 10, all right, 5 10 30 40 50 60 70, and let's say our key is, which you want to get, it's 70. Okay, so here you can see that 10 and 60 will be the answer, right? Our array size is 3 and 4, which is 7. Now let me just do one thing. I'll keep the arrays unsorted just to explain you that we need to sort it first. So first step which we'll do is, you need to, step 1 is, if array is not sorted, then sort the array. This is the first thing. All right, once array is sorted, right, we will take two pointers. One is low. Low is nothing but starting index of the array. We'll take high, which is nothing but the last index of the array, which is n minus 1. Now you will run a loop while low is less than high. All right. So what you will do, you will calculate the current sum, which will be array of low plus array of high. I'm doing the same thing which I just explained you in the diagram. What you will do, first of all, compare the current sum with the key. If this is the condition, that means we got the answer. What we will do here, we'll just print it out. So pair is, our pair is, so we have array of low. All right, and we will see second element. I'll put the comma in between just to make sure that we are able to distinguish between them. All right, so this is the just come out of the loop. If they are not same, there can be two possibilities. Your current sum is greater than the key. It means if your current sum is greater than key, you need to decrement the current sum. How you can decrement? By decrementing the high value, or else you need to increment the low. This is the simplest approach we got. Now we will just run this code once. Okay, so let us do that. Hey, we got the answer 10 and 60. Now if let's say you want 30 and 50, which is 80, let us try with the 80 ones. So hey, 10 and 70, we got the answer, right? Now very important part, I would always say whenever you are working on the data structure algorithms, always think about the time complexity. So how much time this approach will take. This approach, what we are doing, first thing we are doing the sorting. Sorting, we know if we'll use the best algorithm for sorting, it will be of log n. You can use merge sort, you can use quick sort, whichever you want. So sorting will take of n log n, and this while loop here you can see every element we are traversing at max once. All right, so it will be just of n. So total time will be time taken in doing the sorting. All right, time taken in doing the sorting plus just traversing the loop. So it will be nothing but the max of these two, which is of n log n. Right, so we have improved the time, because when we were checking this particular approach, turning to loop, it was taking of n square. Here we are able to solve the same problem into of n log n time complexity. Here we are not using any extra space, so the space complexity will be constant, because we are just using two variables, right? So for every question you need to think about two problems. What is the time complexity? What is the space complexity? And that's good. We are good. All right. So I hope you are clear about the two-pointer approach, how we need to use it, what we can do to make it work. Okay. Now, what is your next target? I would say, please take this screenshot of this particular PPT slide. Here we have discussed these questions. Okay, we have discussed this question. All right, now I would say please give a try for these 5 questions. These, first of all, do not directly start with the two-pointer. Just think about the simplest approach, like running 2 loop, 3 loop, 4 loop, and think about the time complexity, then try to optimize it. So finally you need to use two-pointer approach, and you will see, hey, we are able to optimize the problem. Now in the coming videos I will be covering all these 5 questions. No worries about that. If you are not clear on the two pointer, if you are not clear about this particular question, please comment out. I will help you out. No worries. Okay. Thank you everyone. If you like my videos, please like, share, comment, subscribe. So this will motivate me to create the good content, and I'll make sure I will help you out. Thank you everyone. Bye.